Hi there, hello, Sindre here. In this video I'm going to show you how to make descriptive statistics for statistical distributions using the Stata software. I'm going to make a statistical distribution here that is sufficiently good to be in an international peer-reviewed academic journal. And I know that to be the case because this is how I do it in the papers that I try to publish myself. So let's just get into it. Our journey here starts in Excel. That's usually where our journey starts when you have data sets that are not too big. If you do big data, then perhaps you wouldn't have it in Excel, but nevertheless. We have some nonsense data here that are just simulated. So we have two variables. The variable that we are interested in is height. So this is just the height of some fictitious students of mine. They don't really exist, it's just simulated. And we have their gender. So this is stored in an Excel spreadsheet called dataset and in the worksheet student height. So let's jump over to Stata. There we go. So the first thing you do in Stata, so I'm going to go very slowly through this and incrementally build up the script, just so that we understand all of the details. So first thing I'm going to do is to open up the script editor, the do file editor. So I'm going to type in here, do edit. So one single word, do edit, and I'm going to click enter. And this will open up the script editor. Maybe I can zoom in a little bit here. So first order of business is to type in clear all. So basically imagine that this is like the kitchen bench. We're going to make something. Before we can start making our dinner, we need to clear up the mess from our lunch. Next, I always like to type set more off permanently. This is very useful if you have a loop. Stata unfortunately wants to stop once the screen is filled, and you need to click like spacebar or something or enter just to continue. So if you're going to loop through, let's say 100 different variables and create the same like a diagram again and again, you can need to sit there, click, 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 click. So this is just to get rid of that. Next I'm going to do, I'm going to write cd, which is short for change directory. And this is a command that comes directly from the PowerShell or a command prompt. And I have stored my Excel spreadsheet in this particular folder. So the C drive, users, that's me, Sindre, documents, and I just called it project X. Next thing I'm going to do, I'm going to import this data set. So import, and it's from Excel, using, or perhaps without using, I call it dataset dot xlsx, comma, and it is from which sheet? It's from sheet that's called student height. So if we go back to the Excel spreadsheet, you see you call it student height. So I could have several different worksheets there. So this way I can refer to one in particular. So getting back here to Stata. And we also type in first row. Because at the top there we had like the name of the variable, we had gender, we had height. So if I don't type in first row, Stata will erroneously believe that to be like the first observation, and then you will have a combination of strings and numbers, and we can't really do math because it will force the variable to be defined as a string. So I think maybe it's without using here. So let's try to run that, and let's see, we got an error message. So let's try to put back using. So to execute some code, we forgot actually to select all over. You select a snippet of the code and you click Control D. So D for delta, or D for do, to be more specific here. So as we can see, the data is now inside of Stata. So I can type bro, for instance, that's short for browse, highlight it and Control D. And here we have the data. So what I want to do is to kind of plot the statistical distribution of height. And I can do that with the histogram function. So we're going to type in here hist, which is short for histogram. I don't need to spell out the whole thing. and I'm going to type in the name of the variable, which is height. And then we can highlight it and click Ctrl D. And let's see, here we are. So this will be the histogram of this variable. Unfortunately, this doesn't look quite good. I don't like this vomit green and these baby blue colors. I think we can fix this. And furthermore, I kind of want to add something called the kernel density estimate, because the histogram is essentially just a description of the actual data we have. It's just a description purely of the sample. But ultimately, we want to say something about the population. So what I like to do is to add the kernel density estimate on top of here, which is like one step away from the specific data and a step in the direction of the actual population. So I want to combine two different plots. So what I need to do is to write twoway, and then in parentheses we have the first diagram, and in another parenthesis we have the second diagram. So kdensity, that's the kernel density estimate of height, and if I run this, I will get the histogram and the kernel density estimate. So this is basically the diagram I want to make, and the rest of the code is essentially going to be to tweak the graphical parameters here. Maybe you don't have exactly the same sense of aesthetics as me. Not everyone can be as sophisticated as me, obviously, but you know, you can change this as you want. So the first order of business is that I don't really like to hard code the variable names. So I prefer, let's start by having a comment there. So this is going to be the distribution of height. And I'm going to start off here by having a variable, which I'm going to call the yvar, and that's going to contain height. So rather than hard coding height here, I'm going to replace that with, let's see, with the yvar. That was not easy to do. Let's see. So yvar, and then I'm going to replace it, because otherwise I have to write it twice. There we go. So I can't just run this because this is a local variable, so I always need to run the part of the script that defines what this yvar is going to be. So if I run this too, we get exactly the same thing. So right here, right now, it didn't seem that useful, but it's always a good idea to kind of not hard code the variable names. So the next order of business here is that I want to split this line of code into several lines, because I'm going to run out of space here eventually. But I can't just add enter here. This will not work. If I do this, you're probably going to get an error message here. Yeah, we got nothing. So as you can see back here is something red, something's wrong. And that is because this is supposed to be one single line. So to break it up, I need to use this triple /. If I add this, then it will work. And remember, never do this at the last line of code, because Stata will think that it's going to be something else there, which is blank, and it will just not work out. So let's try it now, and it works. So we can split a line of code into several lines by using a triple /. And make sure there's a space between the syntax here and these 3 /. So next, I want to add some graphical parameters. So within this parenthesis there, I can like give settings, statistical settings for the particular curves, for the histogram and for the kernel density, and I can also do it for the whole diagram. So for the histogram, I think I want a line color that is black, and I don't need to type out all of that. I can just type LC, which is line color, and let that be black. And I want a fill color, FC for short, that I want to be maybe grayscale. I'm going to try 12, for instance. And for the kernel density, I think a red will be a nice color. So let's try to run that. Here we go. And yeah, it's slightly better. Maybe too dark gray color. Let's. I don't remember if I should increment it or decrease it. No, it's the other way around. Let's try 14, so you can tweak back and forth how you want it exactly. Okay, this is starting to look like something. But I don't like the diagram itself, this baby blue color, and the legend here is not very good. We need to fix that. So we need some parameters for the whole thing, not the specific curves. So at the end here, I'm going to write comma and triple forward slash. And down here, I can start to type in settings. So for instance, graphregion color white. And all of this goes purely from my memory, by the way. But if you're starting out with this for the first time, then you probably have to look things up. So here we go. We kind of got rid of this baby blue color, but we still have these grid lines. We can get rid of that too. So one word of warning with the graphregion color syntax. It looks like we got rid of the background color, but it's not quite true. If you import this diagram into LaTeX or into Word, you will see that the diagram has this border around it, like 1 pixel in width of this baby blue color. You cannot see it in the display window as long as you're in Stata, but once you go to Microsoft Word or to LaTeX, you will get that thing. And was surprising a lot of work to figure out how to get rid of that. But if you fire up your Tor browser and go to parts of internet where you shouldn't be, then maybe you'll find this long forgotten forum thread where there are whispers of a certain undocumented command which can fix this problem. And that's the bgcolor, and then white. So if I run that, seemingly there's going to be no difference here. But the difference is that there's some kind of 1 pixel width frame going around this thing. That will be quite annoying when you are in Word. Next I want to do here is to get rid of this grid lines. You see we have this kind of bluish. I don't like them personally, so I'm going to write here ylabel parentheses comma no grid. So that will get rid of it. Personally, I think that's a little bit better. Next here, we have the legend here, and I honestly don't like to have a legend. But so 2 things we can do. We can either just write a legend of. That will get rid of it. Let's try to run that. No, it's gone. But let's say that you do want it. So let's just remove this again. There are 2 problems with the legend, possibly more. It's the wrong names. Like it says density here and then kdensity height. Okay, it doesn't work. And also, I kind of dislike to have it outside the graph because you're stealing space. And this diagram becomes smaller because you're using space for this thing. So I want to put this inside of the diagram. So currently these are in 2 different columns, so side by side. I want to put them underneath each other and move it from outside the diagram to inside the diagram. And I want to put it maybe top right corner. So let's see if we can do that. So we start by writing a legend and then open parentheses and parentheses. And first thing I'm going to do is to say column 1. So currently it's in 2 columns. Now I want it to be in a single column. As you see, now they are stacked on top of each other rather than being side by side. Then I want to move it inside here. So let's try to do that. And that is going to be a ring, not a rinf, I mean a ring 0. So if we try to run that, there's no inside, but it's not in a good position. So currently by default it is placed 6 o'clock. 9 o'clock will be over here, 12 o'clock over here, and this will be 11 o'clock, this will be 3. So I will try to put it in the corner, top right here, so that will be 1 o'clock. So position 1. So let's try to do that. So position 1 o'clock, position 3 o'clock, 5 o'clock, 6 o'clock. You know how it works. And it's like an AM thing. It goes from 1 to 12. There's no 13 o'clock here in Stata. Next, yeah, these names are wrong. And usually I try to put it on the next line here. So 3 slashes here. And then let's see, label 1. And then whatever label happens to be. And then another one, label 2. So the first one is the histogram. And the second one is the kernel density estimate. So let's see if that works. We can run it, and yeah, now it's starting to look good, I think. So what else can we do here? Usually we have like a summary statistics table which says like how many observations are there, what's the mean, the standard deviation, and so on and so forth, and then you have the diagram here like showing the histogram and kernel density estimate. But I kind of like to actually put the summary statistics inside of this table. So down here where the legend used to be, I want to put in like a note there that says like, okay, what are the statistical moments? So let's do that. So what you can do, you can write a note, and then you can write some kind of message, like that. So let's just demonstrate that. See, here we got some text. So let's try to write something actually reasonable here. We can write the mean is equal to something, maybe 3 space there, and then the standard deviation is equal to something, and that the skewness is equal to something, and maybe that the kurtosis is equal to something, and so on and so forth. That you can do. So let's just see how this ends up looking like. Let's run it. Of course, no, I just hard coded some 3 question marks here, so this doesn't look very nice. So I don't want to hard code a specific value inside there. I want to do this automatically. So you mentioned that I have 100 variables. I don't want to sit there and write these 4 statistical moments every single time. So what I'm going to do, I'm going to write sum, that's sort of summarize, and that will create a summary statistics table. So sum, and then we can just take the y variable. So here's another important reason why I don't want to hard code height in here, because I don't want to change it like 3 times now. So this is always yvar, which is defined up here, and also make it detailed. So actually, let me just run that. And if you see here now, in Stata, it will now give you number of observations, the mean, standard deviation, skewness, kurtosis, the percentiles, the min and the max, and all that sort of thing, which is quite nice. But I need to kind of get it in here to the note somehow. So these numbers here, you don't need to copy paste them. They are actually available in something called the return list. So in the return list, all of these numbers are actually stored. Here you go. So I can refer to them. So for instance, if I write display, and then let's see the rmean, it will give me the mean. So let's just run that. You see, it displays the mean that was from the summary statistics table. That's like a secret trick that many people just don't know about. And this is immensely useful for us. So I can actually just write rmean down here. But there is one issue with that. That is, it's usually too many decimals. So let me just put in this here. And we can also get rid of that. So let me just run this again for you. We get the diagram, and as you can see, it's way too many decimals. Don't like that. So let's try to fix that. So what I'm going to do, I am going to create another variable, local rmean, that's just a name I came up with. It's going to be equal to a string of the rmean, so that's from the return list over here. And we're going to give it the format of 2 decimals. So it's down here, we can refer to this new variable that we made. So if we do this, there you go. Mean is 175 centimeters and 43 millimeters. Yeah, so we can do this for the other statistics. Let's just copy paste this a few times. So we have the standard deviation, that's SD. So from the return list, you can see what the different codes are, but I just happen to remember them. Maybe I want the skewness, so rskew. So this right here are names I'm just coming up with. I could call it whatever I want. I just want to call it basically the same, just without the parentheses. And we have the kurtosis, for instance. Maybe I also want to have the min and the max and number of observations. That should be sufficient, I believe. So min, and then max, and then the number of observation. So that is capital N for observations. We don't need any decimals, so I'm going to change this from 2 decimals to 0. And let's see here, we need the min, and here we need the max. And then we just populate this inside of here. So let's see. So this was the standard deviation. And this would be the skewness. And this right here, oops, I'm a little bit struggling here, would be the kurtosis. And I'm probably running out of space on this line. Let's run it and see how it looks like. Type mismatch. What did I do wrong? Hold on a second. RSD, let's see. So the mean, the RSD, the rskew, the rkurt. Why is it not happy about that? Is it something wrong up here maybe? Yeah, so error is up here somewhere. Let's see, we can do some decoding here. So that works. So maybe I misremembered some of the, yeah, skewness and kurtosis. Maybe that is the error. Yeah, that works, okay. So maybe I didn't remember all of these codes after all. But that's okay, we can fix that. So as you can see here, we have the mean, deviation, skewness, kurtosis, a little bit small text. So maybe I want this to be bigger. So maybe we can say that size is medium. Maybe that works. Yeah, so a little, no, that did not work. Maybe it's a comma there. Let's see if this works. Yeah, so that's a little bit bigger, a little bit more readable. But we do run out of space then. So what I'm going to do here, I'm going to split this on another line. And actually this can also be split. Am I able to keep this on one single line? Yes, there we go. So on the second line, I'm going to have the min, which is going to be equal to rmin. So this is a little bit tedious, so usually you type this at once, and you can just reuse the script again and again. And then we have the max. So this is probably boring to watch, but you can probably just skip a little bit forward if you are impatient. But patience is a virtue. There we go, okay. And finally here we need to have this. So if we run this now, I think we have decent statistical distribution. So this is how I usually do it. Except we have forgotten something here. We have forgotten to add like a y-axis and x-axis title. That we need to fix immediately, of course. So we are almost done here. So I think I'm going to put that up here. So the code is y-title, y-title. And in here you put the y-title. Then similar, x-title, another one. And you can write whatever you want in there. And also, if you have 2 axes, then you can come up with 2 different y-titles. You just have to make one with axis 1, and then you could just create another one that is for the second y-axis. That is something you can do. We don't need that right here for this particular diagram, so we can just leave it like this. So 1 and 2. You could hard code the name in here, but I don't like to do it that way. So I'm gonna go up here at the very top, local yname something, local xname. So this is student height in centimeters. Of course, this variable doesn't matter. It's something, right? And here we have the density, and then we can refer back to it over here. So this would be the y name, and let's see, over here we have the x name. So let's try to run that. If we run this, Then yeah, density and the student height in centimeter. So that is basically how I like the diagram to look like. Let's zoom out a little bit there so you can see the whole code. So we start by, this is the variables going to be used, the y variable, the names. Then we run some summary statistics there to put inside the note. Two-way means we're combining two different curves into a single, or as many different curves as we want into a single diagram. We have the histogram, line color black, the field color is some grayscale. Then we have the kernel density estimate with the line color red. And there are different types of kernel density estimates you can run in here, so you can just specify. Sorry, and by default it's going to be the Panchnikov, but you can change the different ones there if you want. Then we have some of the aesthetics there. We want to get rid of the background color, which was baby blue. bgcolor to get rid of this frame going around it. Get rid of the grid lines, y-axis title, and then the x-axis title. We did some change to the legend, and also added this note, which relied on defining some variables from summary statistics table up over here. So the final thing we kind of need to do here is to save it. And I can go here and click manually to save it, but tedious, very tedious. So you can just automate it. So down here I like to write local file name. That could be, gonna hard code it, distribution of what exactly? I could write in here like this is height, but I like to just refer to the y variable. So the name is going to be distribution underscore height. And then we need to actually save it. So graph, save, and then file name dot gph. So that's Golf Papa Hotel, and that is like that is the Stata format, this thing right here. So it's not possible, of course, and I closed everything here, that's not good. It's not possible to open up the GPH without having Stata installed in the computer. But if you do that, you will get this thing, and you can start here actually manually with the graphical user interface, I mean, to change the different parameters. But we are doing automatically now with the script. But this is not going to be useful for you when you want to put it into your report, into your LaTeX document in Word. So we need to actually export this. And by the way, we can also type in here replace. If you don't have replace and you want to rerun this, so if I want to change or tweak some settings here, then it will say sorry, but there already exists such a graph. You know, you can't oversave it unless you have replace. So I see graph export, and then basically the same thing. But we need to change it from GPH to whatever format you prefer. So if I wanted to put this inside of LaTeX, I would usually go for the PDF. If I want to put it into Word, so let's say, so this is good for LaTeX. This is just like the Stata. And if I want to put it into Word, I usually go for a TIFF format. I find that to be a good format. I think it's a capital X here. So this would be for Word. And when it comes to, if I have a loop and I'm like creating 100 of this, I don't know about to double click on every single TIFF file to open up and see it. So I actually like to also create PNG. Because if you open one PNG, you can use the arrow keys on the keyboard and just click, 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 go through them really fast. And also, if I want to copy this into to an email, then it needs to be a PNG. So let's just do it like this, PNG. And then let's try to run it. So let me just move it over here. So if you run this whole thing, you see here, it saved it in the 4 different formats. So it's going to be done in your folder. So this folder is where we have the Excel spreadsheet with the data, and we automatically created this different versions, different formats. So that's how you do it basically. This is how I make statistical distributions in Stata for the type of when I do research, when I want to publish a paper. So this is the entire code. There are some additional things there that I want to also mention before we stop this video. That is that you can actually put in if conditions here. So for instance, if you noticed, if I go here and show the data, we have the height here of some students. How many are there? 244 students. And well, we also know their gender. So presumably, I think 1 here means that you is someone who identifies as a man, and 0 will be everyone who does not identify as a man. So we could actually be interested here in disaggregating this, only looking at not every student, but only look at men, for instance, and everyone who is not a man, which presumably in most cases would be a woman. So we can do that actually. So let's open up the script again. Where did it go? Here it went. Yeah. So I like to put in here what I call the local zvar, and that is my condition. So the condition here would be gender, or the variable we put the condition on. So over here in histogram, I can say if the z variable, the Zulu variable, is equal to, let's say, 1, which I think that's a man in this case. It's important here to put a double equal sign because we're testing for equality. Single equal sign is to assign a value, and double is for equality. So let's say that it has to be equal to 1. We need to do this 3 times actually, so both for the histogram and for the kernel density, but also up here when we do summary statistics, like this. So if you now run it, I'm not going to save it this time, you see it now looks a little bit different. So I'm going to open up the PNG from previously, so we can compare them. So you see here, this was for every single student. This was for just the, presume this is for the men. And if I wanted to look at the women, I would just change this once into a 0. And actually, I had to write this 1 3 times now, so maybe I should have put it up here and just refer to a variable. So what I realized, many people are also interested in knowing if this is normally distributed. And we can run a test for that, the rkurt beta test. Yes, it's the rkurt beta test, which of course is referred to sktest in Stata. So I just remember we can add that too. So if you run an sktest on the y variable, if the set variable is equal to 1, if I do that, I think it's p-value. Let's see, return list. So I thought we were done here, but I just remember there's something more we can put in here. So that is referred to as the what is that? Yeah, the chi, yeah, I think, yeah, p-value chi2. So we can just copy this line of code, for instance. So this would be the p-value from the R list. It is the p-value. So it actually runs 2 tests, the rkurt beta test. It looks at both the skewness and the kurtosis, because if it's going to be a normal distribution, then you need the skewness to be 0, so it doesn't skew either direction. And you also need to check that not the kurtosis, but the axis kurtosis is equal to 0. So it's like 2 tests run together. So see the aggregate outcome here, that would be chi2, I think. So we can put this inside the note if we want. So down here I can write, I'm not sure how you spell rkurt beta or how to pronounce it. Rkurt beta normality test colon, the p-value is equal to the pval. So let me run this. Parentheses do not balance because we forgot here to add the line breaker. So you could do that. There we go. Now it's starting to become a little bit crowded, so maybe you don't want to do that, but just like an additional example. So yeah, this is basically how I make the statistical distributions in Stata. So as you can see, very fast, becomes a little bit messy, but do this once, then you can just automatically do it for all the kind of variables you're dealing with. So maybe one final thing here, I really should stop now, but one final thing to mention here is that what if you want to do this in a loop? So for instance, what if what if I had students for many, like for a 10-year period? I want to do this for like every year, for instance. I can put this inside of a loop. So this whole thing would be inside a loop, and I would loop to different values of the condition. So instead of looking at gender, maybe I would be looking at the year. So I could just change this to year. And let me just show you how a loop would work. So the loop would be 4 values. I is equal to 1 to, not 1, let's say I had students from 2015 to 2022. And then inside here, you would have basically our script here. The only thing we need to change then is to not hard code a 1 here, but refer to the actual I here. So I will replace the ones here, which previously referred to men, replace that with an I. So I don't want actually to do that right now. I'll just demonstrate that the loop works. So just display this I. So it would run this script 7 times. So see, so 2015, 16, 17, 18, 19, 20, 21, 22. So yeah, actually, video's long already. We can just copy paste this and show how that would work. So I would put this inside the loop. So by the way, just like a demarcation here. That's a different graph. So over here, maybe we put some indentation to this, like this. Loops can be a little bit difficult to pull off. Sometimes you get it wrong. So this will just call it. We don't actually have a year here, but we could have written year, and then refer to the I here. Just going to make the code without running it, because we don't have an actual year variable, but just hypothetically speaking. So it will do this this many times, and you substitute in a different year. And down here in the local file name, I will probably add in here year and the I. Otherwise, it will just keep saving over the same file. So now we have a loop. So instead of copy pasting this for every single year for 2015, 16, 17, all the way to 2022, you just put inside the loop, and that's how you do it. So yeah, that is basically it. This is what I do mostly throughout the day when I'm not lecturing, doing descriptive statistics like this, and then occasionally running a version. I'm just gonna try to display the whole script there as big as possible. Yeah, so this is the whole script. Hope you learned something. If you liked it, you can like, comment, and subscribe. See you for another video. Paka paka. До свидания. Yeah. How do I turn this off?